you a definition or give you characteristics or information, you can only make a decision based on that information. So when it says that a parallelogram has four congruent sides, that's all you know. So what's the most you can say about that parallelogram? John?
It's a rhombus.
It's a rhombus. Square needs four right angles also. And it doesn't mention right angles, so I can't make that determination. So the most I can say is rhombus.
Yes.
What's the most I can say about a parallelogram with four right angles? Rectangle. Now, if somebody gave me information about both, then I could say it was a square. This term is of my own making. You're not going to see that in the textbook. When I say extra characteristic, I'm always referring to what segments. So I know something about the diagonals is going to be mentioned. What is the extra characteristic of a rectangle and diagonals? That is actually a parallelogram characteristic, and it's not considered extra. Because we're already saying it is a parallelogram. We're going to be more specific and say that's the result, that it's symmetric, and they're symmetric because the diagonals are equal. Diagonals bisecting each other is considered a core characteristic of a parallelogram. Now we're attaching more to that. Rhombus, you could have two. Either the diagonals, well, somebody give me one.
Diagonals are big angles, or bisect big angles.
Diagonals bisect big angles. Not a great technical definition, but we know what we're talking about. And if I wanted to, name another, what else about the diagonals?
They're perpendicular.
They are perpendicular, which means what degree measure? So 90 degrees is going to show up in the center of a diagram with two diagonals. What's the definition of a trapezoid? All right, and let's make it a little more specific. It's a quadrilateral with exactly one pair of parallel sides. I urge you to go back to the note sheets that we had with the three pictures, stare at them, embed them into your brain. Before you do any problems with quadrilaterals, name what you're looking at. If I have this, what does that make that figure? So write that down. That means you can That means you can only deal with parallelogram characteristics. Someone raise their hand. Tell me what X is and tell me your justification. Cameron?
Put X is 114.
X is 114. What was your justification?
When you add 28 and 38, it's 6, and then you subtract from 180.
Okay, so next to this drawing, put another drawing, even if you didn't. She took 28 and 38 and she added them together and got 66. And just looking at the big picture, she decided that those two angles, since it's parallelogram, are supplementary. So 180 minus 66 gets you to 114. That was one way to do it. Look at the big picture, take these two angles, put it there, and then these two have to be supplementary. Or you could have started with 17. Did anybody start by just writing 28 there?
Yes.
Yes.
Why are you allowed to write 28 there?
Alternate.
Did you look through the Z shape? 28, 28. And then you could have stepped back to the X, and don't we have a triangle here? How many people just looked at the triangle and then added up 28 and 38 and subtracted from whatever? So you could have either done a triangle method for X or this method. I'd recommend always having this in the back of your mind. Usually it's helpful to take out the diagonals and think of the big picture. If I have 4 equal sides, what am I looking at? Rhombus. As soon as I see that a rhombus is mentioned, not only are the sides equal, but other stuff is equal. If I've got 46, I've got 46, and I've got 46, and I've got 46. Done. Didn't we just say over here, oops, didn't we just say up top that the diagonals bisect the big angles within a rhombus? Well, that's exactly what's happening here. The big angles are getting cut perfectly in half. Even though it wasn't part of the question, I might put next to this a big picture diagram where I have 92 and 92. This would be 88 and this would be 88. It wasn't asked for, but maybe in another test, another quiz, you would need that information or would have to figure it out. Good to know.
I didn't get it a simple way. I did it because I thought it was all equal.
So he considered that this was isosceles. So this angle's always got to be equal to this one. This one's got to always be equal to that one. Many ways to get at the same answer. What are we looking at for 18, 19, and 20? Rectangle. As soon as I write the word rectangle, I'm going to also do this. All of those are equal because the diagonals are equal. We wrote that down up here. We said diagonals are equal for a rectangle, which means all the little pieces are all the same. What type of triangles do you have in here now? So I'm thinking about that as I'm filling things in. I know that this is 37, 37, 37. Left to right looks the same. Top and bottom should look the same. That's 53, that's 53, 53, 53. I think that's enough to answer these questions. Let's see. X is 37. Y turns out to be 53. Can we determine Z?
Yes.
Don't we have a triangle? 106, so 74. We're moving pretty quick through this. If you want to know where something came from, slow me down. Very symmetric. Any questions on the rectangle? Now we've got, instead of angles, we have some lengths. These are the diagonals. What kind of shape is this? Rhombus. Well, I know that in a rhombus, if I see two diagonals, that I should be putting right angles right in the center. It's still a parallelogram, so the diagonals get split, they just don't get split evenly like in a rectangle. So if AC is 24, I know I have 12 here, 12 here. If I've got 32 from here to here, what are the two little pieces? 16 and 16. If you draw it that way, it's a little bit easier to see that this is a right triangle problem. I'm trying to find this. Isn't that just the hypotenuse of this right triangle? So I'm going to separate out A, X, no, sorry. Well, I didn't, is there any letter on your drawing for the center? No? A to D, you got 16 here, right angle, 12. Can you do Pythagorean theorem?
Yes.
Yeah. If you're stuck, it's probably because you're not thinking of some triangle characteristics, even though it's a quadrilateral problem. So C squared, we'll call this C. $356? 256, thank you. And that makes sense. That's 400, square root of 400. Did we get 20? So you could have done this with sine, cosine, and tangent if you... No, you couldn't, because we didn't have any specific degree measures, so this was the only way you were going to be able to do it was Pythagorean. And that's the order you should think. What was the king of chapter 7? Pythagorean theorem. Then you move on. If you can do special right triangles, you do that. If you can't do that, then maybe you can do sine, cosine, and tangent. And any quadrilateral that has right angles showing up in it, whether it's a rectangle, a rhombus, you've got to start thinking about possibly right triangle. Let's finish this. This was 12. That was 20. Any questions on what we went over? There are so many different variations of what you can jam into a quadrilateral that I can't possibly go over every single type. You'll have plenty of time to work on these 34 problems that are all multiple choice. Bring some scrap paper with you. I don't think there's enough room to do all your work on here. There's some. Let's take a break from quadrilaterals. Did we break apart the circle yet? No. All right, let's do that.
That's for Friday.
Well,